This is part 2 of the video, so make sure you've watched part 1. This is about the radius and interval of convergence for power series. Now, we already talked about how to find the radius of convergence by using the ratio test. Now we're going to talk about how to find the interval of convergence. Okay, now to find the interval, you've got to know the radius first. So the beginning of this problem is going to match exactly what we were doing in the first video. We run the ratio test, which means we do the limit as n approaches infinity, and we put the original on the bottom, and on top we add 1 to all the n's. Now I need to multiply by the reciprocal, and all the x's will cancel out except for one of them on top, leaving the xn over n plus 1. Okay, now remember your rules about the powers of n. If the powers of n are the same, then the limit will be your coefficients. So your limit is going to be x over 1, or just x. So our limit is the absolute value of x. Now if you recall, the ratio test says that if your limit is less than 1, then you converge. So if this is less than 1, then we converge. And that tells us that our radius of convergence is 1. Whatever this number turns out to be when we simplify, turns out to be 1. Something I'm not sure I said in the first video, so I'll make sure I say it now. You can simplify out of an absolute value by multiplying and dividing. You cannot do it by adding and subtracting. And if you look back at the 2 examples in the first video where this happened, you'll see that. So you can multiply and divide out of it. You cannot add or subtract out of it. Alright, now that we know the radius, here's how we go about finding the interval. If you just think about a number line for a second. We need to first find the center. Remember, the center is the number that we plug in for x that would make the whole equation 0. Well, that's often going to be what it is here, and that would just be 0. So 0 is our center. We always are going to converge there because it makes everything 0. Now, the fact the radius of convergence is 1 tells us we can go up 1 or down 1. So we know our interval is going to be from 1 to 1. It's just a question of if we include, negative 1 to 1, sorry about that. It's just a question of whether we include the negative 1 and positive 1 or not. In other words, do we do parentheses or brackets? And that can vary depending on which one we use, and you'll see that here. So the way to figure out if you're going to do parentheses or brackets, if you're going to include negative 1 and positive 1 or not, is by actually plugging these values into your equation. So we had x to the n over n, so I just plug in negative 1 for x to test the negative 1. Now that's an alternating series. In alternating series, the rule was if you took the limit of it without the negative 1 part and got 0, which you do here, then it would converge. So we find then that if we plug negative 1 back in the original, it does converge. So that means we can include and should include negative 1. Okay, now on the other hand, if we plug in positive 1 for n, we just get 1 to the n over n, which is really just 1 over n. That's a p-series, and that particular p-series diverges, because if the power is 1 or smaller, the p-series diverges. So positive 1, when we plug it back in the original, diverges, which means we would not include 1, so we must put a parenthesis around it. So our interval is negative 1 included to positive 1 not included. And that is our interval of convergence. Again, what that's telling us is what values of x we can plug in to our power series and converge. Okay, let's try this next one. Same question. We're going to be finding the interval of convergence. Okay, we have to start by finding the radius, so we do the limit as n approaches infinity. We put the original on the bottom. On top, we add 1 to all the n's. You remember, I don't have to put the negative 1 to the n because of the absolute value signs. Now I need to multiply by the reciprocal. And we'll see that all the 2's cancel out, except for 1 on the bottom. All the x plus 1's cancel out, except for 1 on the top. So we're just left with x plus 1 over 2. Now that does not allow, or excuse me, that doesn't have any more ends, so that means we're done. The limit's already been taken, because these are just all coefficients and constants, or constants, the word I should use there. So the limit's finished. Our limit is x plus 1 over 2. So what the ratio test says is that if our limit is less than 1, again, I'm not stating that's always true, I'm just stating that this is when it converges, when that's true, then we'll converge. So if we're less than 1, we converge. Now we need to simplify this, and like I said before, we are allowed to multiply out of it, because you can take the absolute value of 2 on the bottom and it's just 2. So you can write absolute value of x plus 1 is less than 2. You cannot add or subtract out of it. So that's as far as we can go. We cannot subtract the 1 out of there. That would very much break the rules of absolute value and how that operation works. So 2 turns out to be our radius of convergence. Okay, so let's think about our number line again. We need to start by finding the center. Well, look back here. What can we plug in for x that will just turn the whole thing to 0? Well, this time it's going to be -1. That's our center. If I plug in -1 for x, that is what will make the whole thing 0. Since my radius is 2, that means I can go up 2 to +1 or down 2 to -3. So I know my answer is going to be -3 to +1. It's just a question of whether I'm going to use parentheses or brackets, whether I'm going to include or not include -3 and +1. So again, the way we find that out is to actually go up there and plug in these values. So I'll try -3 first. If I plug in -3 for x, that gives me -2 to the n over 2 to the n. And you can actually simplify the top there, since they're both raised to the n, and get that just 2 to the n over 2 to the n, which just goes to 1. Now I'm being a little lazy here. I really need to write this. So think about that for a second. If my sequence is just 1, and I'm adding that up as I go to infinity, would that converge or diverge? Well, clearly that's going to diverge. If you keep adding 1 over and over and over, it's just going to get bigger and bigger and bigger. So that tells me I diverge when I plug in -3. So I put a parenthesis around -3. Now I need to try plugging in +1. So if I plug in +1, I get 2 to the n right there. So I'll have -1 to the n times 2 to the n over 2 to the n. My 2 to the n's cancel, and all I have is -1 to the n. Well, all -1 to the n does is alternate between -1 and +1, and -1 and +1, and -1 and +1. So that's also not going to ever converge. You can apply the alternating series test there, because if you take away the -1 to the n, it just leaves you with 1, and the limit of 1 is 1, and that's not 0, so you would diverge. So neither of these endpoints can be included. We can go all the way up to them. You can do -2.99 and so on, or 0.99 and so on, but -3 and +1 will not work, so we have to put parentheses around them. So our radius of convergence is -3 to +1. Okay, this example we're going to find the radius and interval of convergence here. So we need to do the ratio test. Remember, if you have to do the interval, you have to find the radius on the way anyway. So we put the original on the bottom, x to the n plus 1 over n plus 1 factorial, and then x to the n plus 2 over n plus 2 factorial, because we have to add 1 to the n's. So now I need to multiply by the reciprocal. I'm going to rewrite this as n plus 1 factorial times n plus 2. And this will be the reciprocal. So the n plus 1 factorials cancel. And if you look, I have one more x on top than I have on the bottom, because it's x raised to the n plus 2 on top and n plus 1 on the bottom. So all the x's cancel except for 1 on top. So that leaves me with x over n plus 2. So if I take the limit here, n is going to infinity. That means the bottom is getting huge while the top is staying constant, because we're treating x like a constant. So that means the limit is 0. Now we said earlier, if the limit is 0, that means we always converge. And if we always converge, then our radius of convergence is infinity. Well, if our radius of convergence is infinity, that means we converge everywhere. So my interval of convergence would simply be -infinity to positive infinity. Our center for this problem is 0, but that's really irrelevant because no matter where our center is, if we go up infinity or down infinity, we can go all the way. So if the radius of convergence is infinity, the interval of convergence is all real numbers or negative infinity to positive infinity. The only other scenario you might run into is one like, I'm going to actually go to an example we used in the previous video. Let's see where it is. Here we go. In this particular example, we found that the limit was infinity, and that told us that we diverged everywhere. And if we diverged everywhere, then the radius of convergence is simply 0. Now, if the radius of convergence is 0, that means we don't converge anywhere except at the center, because the center always converges because it makes everything 0. So our interval of convergence would really just be a single point here. So our interval of convergence would be at the center, which would be in this case at x equals 0. So we've got three possibilities. You may have an interval at just a single point, you may have the interval from negative infinity to positive infinity, or at a set interval around your center.